Hi everyone, so today we are here with a new problem which is permutation 2 of Leetcode. It is a medium type of problem and today we see what is the problem and then we see how we can solve it. So in this problem we have given an array nums which may contains duplicates and we have to return all the unique permutations. So first of all you have to understand what is permutation. So permutation means if we have a set of elements, then how we arrange those set of elements in different order, we get different permutations. Okay, let's understand this through some example and say let's see what is the problem. So as you can see in that case we have array like 1 1 and 2, and here 1 is 1 and 1 is both are duplicates. Now permutation means let's suppose these are the elements we have, so how we can reorder in different thing. So first this is one order, we can see it. The another order is 1 2 1, right? The another order is 2 1 1, right? Now the basically the approach we are going to use in order to find the permutation is always like what we do. Previously we take one element, let's suppose we take 1, right? And for the 1 2 we can write like 1 2 and 2 1 and add 1 in front of it and they add 1 in front of it, so we get these two permutations. But right now what is the problem at this point? The problem is we have 1 and 1 two times, so in that case this 1 1 2 can come two times. Why? Because if this one is there and this one is there, we get 1 1 2, and if we interchange these two 1, we also get 1 1 2. Now you can see this and this both are same, so we don't need it because we want unique permutations. Okay, and as you can see this is unique, all the elements are unique. So how we find the permutations? Okay, as we know before how we find the permutation, let's suppose we have 1 2 3. So what we do, we basically place 1 here and write 2 3, and then interchange like 1 here and interchange 3 2. Similarly we take 2 and write 1 3, and similarly we write 2 and 3 1, and now in that case there is 3 1 2, and here we have 3 2 1. Now this is all the permutations and it is very easy. For each element we put it in the starting, and for the rest of the element we change it. Similarly for 2 and similarly for 3, and we get all the permutations. But if the some elements are duplicates, then there is a problem we have. Okay, mostly these type of permutation combination problem are solved using backtracking, right? So what is backtracking actually? Let's understand first backtracking and then move ahead. So basically there is some initial input we have. Okay, so here the green is the start point where we have the input, and blue is the intermediate point. Intermediate point, it is in the processing mode, and red points with no feasible solutions, and dark green is end solution. So what is happening, we have some input, we have some intermediate state where we process those inputs, and at the end we get some output. But here some output are feasible according to our constraints and some output are not feasible. So the output which are feasible we accept that, and the output which are not feasible we don't accept it, right? And here when the algorithm propagates to an end to check, so basically you can see this is a branch and this is a branch, we come to a point and let's see we don't find any answer, so we come back, then we propagate another line, we propagate another line, we don't find answer, we come back, we find another. So basically that is a backtracking. We go find a solution, if it is good, if it is fine with our constant, that is fine. If it is not, we come back, try another solution, and that's how we are going to do this. Now let's see how we can solve this problem using backtracking. Let's see the example of duplicate array which is 1 1 and 2. What is happening in the backtracking? Basically we have some points, and we actually we have some intermediate points and we actually explore that points, right? But if you can see, if we explore, if we take 1, right, the remaining things we have is 1 2. So we explore like we can add one first and two after that. What I mean by this, let me show you. So what I am saying is, let's suppose I consider one, right? The remaining thing is one, two. Now I have a choice. I can add one and this one like that, or I can do one and two. It means from this we can include one or we can include two. If we include one, we get this type of set. If we take two, we get this type of set. Okay, and if we take one, we have two, and if we take two, we have one. Now it contains it only consists one element, so we can add it and we get one and two. And if we add here, we get one, two, and one. Now if we take this one, right? If we take this one, you can see this same structure we get. The remaining is again one, two, and this again same structure forms down, right? So basically, for the duplicates, let's suppose this one and this one is duplicate. For this, we only have to create one tree structure, not create the another tree structure, right? So how we are going to solve it? So for this, we are basically using a hash map. We are basically using a hash map and then solve it. How? Let's see. Let's go down and let's take the example again, which is one and two. If I create a hash map of it, so how it looks like, the one comes two times and the two comes one time, right? This is the hash map. Now we don't take this as our input, we take this as our input, and now you can see we have 1 and 2 as the only two elements, and we have to rearrange it. How we have to rearrange it? Let's see. So basically, we start from there and we take 1 and we take this hash map. So if I use this one, so the remaining things are 1 again, so there is only 1 remaining and there is only 2 remaining, right? Now what we can do, if I attach 1 to it, it looks like 1 1, and our hash map looks like, so 1 is used, 2 is there. And if we attach 2, so it looks like 1 2, and our hash map looks like 1 is there but 2 is used. Similarly, if I go down, 1 is not there, so I can't use 1 here, so I can only use 2, so I use 2. So this hash map exhaust and we get 1 1 and 2. And similarly, there is only 1 remaining, so we have 1 2 1, and our hash map is exhaust. Now this is the first element we take. Now the second element is only 2, and the remaining things are 1 exists 2 times and 2 is exhaust. Now we have the approach. What if we take this 2, right? uh, then we can add 1. um, okay, so what we are going to do is, we are going to add 1, and the hash map looks like 1 is remaining 1 time and 2 is exhaust, right? So in that case we can't use 2 again, so we can only use 1 here, right? So this one is used and everything is exhaust. This is exhaust and this is also exhaust. Now in that case we only get one branch. Why? Because there is only one element, that is the power of hash map, right? If we don't have a hash map, we have array. So how it looks like? It looks like 1 and 1. In that case we have to consider this one and we can have to consider this one, but now in that case we can only consider this one because 2 is not there, so we have to consider 1. Now there is there is for the second element there is no such uh, existence, so we can't use it. That's why we have to use one. And that's how these three are the permutations. These three are the permutations we get, right? So I hope you get it. Now let's see the code. It makes more sense to you. Okay, that is the diagram. Let's see the code. It is very easy as that. So basically, this is the array that we have to return as an output which contain all the permutations. This is the temporary answer, which is an array which is storing these things 112, 121, 211. Okay, so that is the temporary answer, and this is the dictionary we have. So you know how to create the dictionary. We are just creating hash map here, and after that, this is the we can say end condition, right? Where we have to stop our backtracking. So end condition says if the temporary answer, it means the storing array, if its length is equal to the length of the array, then we have to stop and we have to append it. Answer is appended. Uh, so temporary answer is copied and appended to my answer array. And similarly, we will check for any I value. If there is an existence, we will append it and call this function again. And after using that, we have to increment it and pop it from the temporary answer. As you see in this solution array, how a solution tree, how we are going back and we get all those things and all these things. So that is the whole thing we are doing, and at the end we have to return the answer and you are getting the solution. And this is very helpful in understanding backtracking approach. You can solve it, understand it, dry run it for more understanding. For any other confusion, for any other explanation, you can comment out and we will surely help you. And thank you. Bye bye.